So I'm going to build slowly towards this western boundary intensification because it has many concepts, and it's the total concept of western boundary intensification is very important. So let's make sure you understand each piece. Okay, so here is a nicer view of the subtropical gyre. Now we have shown it with this slight east-west asymmetry. The north-south asymmetry is not that important in terms of the dynamics. So what is it showing? It's basically showing a narrow and strong flow northward on the west, and a broad, shallow, weak eastward, southward flow in the east. Okay, so keep carrying your fundamental understanding already. This northeast trade and mid-latitude westerly circulation has created a gyre, and the Coriolis increasing with the latitude has created a southward flow, right? Because of this increasing Coriolis with latitude. And the geostrophic current around the gyre is balancing gravitational force and Coriolis force, and moving in a circular path down the hill. It cannot come down straight because of Coriolis. It has to keep coming down like a spiral path. This is a idealized geostrophic flow. As we said, friction effects are ignored, but friction is what generated the dome, and that's what created the pile of water in the first place. So the main concept now to explain then is, why is this western boundary current narrow and strong and deeper? Why? What is the main reason for it? Okay, so here I'm going to add another concept called vorticity. Many of you are probably already aware of it. It's the tendency of a water parcel to rotate around its own axis. It's different than circulation. This water that's going around the gyre down in a spiral is just circulating. What's the difference? Let's say you are on a merry-go-round. Okay, you stand on the merry-go-round long enough, you've been circulating around the axis of the merry-go-round. Let's say you went for too long. When you get off and you try to walk, if you've been on it long enough, you probably start wobbling. You feel giddy, right? That's because your brain is now experiencing a lack of balance, because there is this rotational effect you have gathered by being on this circulation. So everything on Earth is on a rotating framework or a merry-go-round, and if you displace it, like getting off the merry-go-round, it's going to have a tendency to rotate. That is vorticity. Okay, just remember it. If you can't distinguish mathematically between circulation and vorticity and so on, just remember that everything on a merry-go-round has a tendency to be giddy or have a rotational effect. Okay, so what are the winds doing to the ocean? They are churning and creating the gyre circulation, but every parcel on this gyre is also getting a rotational effect, a vorticity. What is the sign of the vorticity? Here you have to recall your fundamental physics, where you use the so-called right-hand rule. What is the right-hand rule? Basically, you curl your fingers for something, and the direction of whatever quantity you are thinking about is along the direction of the thumb, right? So here we are going to look for the sign of the vorticity generated by the winds in the ocean. How do we do that? You curl your fingers around the direction of the winds which are creating the rotation. So you have the northeast trades in the tropics and the westerlies in the mid-latitudes. And imagine a horizontal surface on Earth, right? So if you curl your fingers around the northeasterly trades and the westerlies, the thumb will point down into the ocean. Okay, so if X is the direction of the longitude, Y is the direction of the latitude, then your finger is, and Z or Z will be vertical from the surface towards the sky. So you have west to east is positive x, equator to north is positive y, positive z is from the surface to the sky. Okay, so if you curl your fingers around northeast trades and westerlies, you're going to point your finger into the ocean, which means in the negative z direction or negative z direction. What does that mean? That means winds are putting in negative vorticity into the ocean. So, is it getting complicated? Not really. Winds created a gyre motion. Coriolis created a southward mass transport because of the increasing Coriolis effect. So westward flowing north, but not as much as eastward flowing south. And the winds are putting in negative vorticity. All the forces in a system have to be balanced. Otherwise, if the winds keep on putting negative vorticity, ocean will keep spinning faster and faster and faster. And the water will keep coming south and keep piling up on the equator, and that doesn't happen. Why? Because something in the ocean is taking the mass back north to balance this south coming water because of the Coriolis increasing with latitude, and something is balancing this negative vorticity being put in by the winds and creating positive vorticity to balance the negative vorticity by the winds. So winds are creating southward transport, negative vorticity, and something is creating a northward transport to balance the southward transport and a positive vorticity to balance winds' negative vorticity. And we will see that in steps, but just to say that, it turns out that this northward transport of water to balance the gyre transport and also to produce positive vorticity can only be done in the west. So large gyre is moving water south. You have to move the same amount of water north, and you have a small space to do it. So the currents are going to be fast and deep. Large volume of water moving south has to be moved back north in a tight space, so it's going to be narrow and deep, and it's going to have to produce positive vorticity to balance the negative vorticity by the winds. Okay, this is the concept of why you have western boundary intensification. Till the 1940s, this was not even known. What is causing the Gulf Stream? A genius called Henry Stommel at the Woods Hole Institute of Oceanography and Harvard University. He moved around a little bit as a student and then as a scientist and a teacher. He was the first one to show that because Earth is a sphere and Coriolis increases with latitude, you end up with western boundary intensification. So the Gulf Stream, the Kuroshio, and the Somali Current, Brazil Current, East Australian Current, and so on exist. These are the western boundary currents, including Oahu and Labrador and so on. All the western boundary currents, intensified western boundary currents, exist because Coriolis is not constant. Okay? So as long as the Earth is a sphere and it's rotating, we are going to have intense western boundary currents. Okay? Why do I say that? Because under global warming we have to see what happens to the western boundary currents. Okay? As long as the Earth is sphere and it's rotating, it has latitudinally increasing Coriolis effect, and it will have western boundary intensification. Something to remember. Okay? Very important concept, but make sure you understand. Make sure you